Okay, let's look at some examples from 1.2. So it says for each function, describe the end behavior verbally, write limit notations for the end behavior, and then write the equations for any horizontal asymptotes. All right, so what do we have here? Well, if we think about this, this is really just y equals mx plus b, where we have a slope of 5 and the intercept of -7. And so if we really graph that, what is that going to be? Well, we have the intercept of -7, we have a slope of 5, so it's going to look something like that, just in general. We don't have to have an exact. And so the end behavior, well, the end behavior is going to go, that direction and that direction. So uh, as x goes to -infinity, output, or f of x, or m of t rather, I guess in this case, m of t goes to -infinity. And here, as x goes to +infinity, m of t goes to +infinity as well. All right, so that would be kind of A, the verbal. Now B, write the limit notation. So what we can say is the limit of f of x as x goes to -infinity equals, well, as it goes to -infinity, that's -infinity. And here we can say the limit of f of x as x goes to +infinity. Well, as we go to +infinity, that's going to be equal to a +infinity. So that would be our that. Now, is there any horizontal asymptotes? Does it approach any numbers? No, there's no horizontal asymptotes, so there's none basically for this example. Okay. Now the next one, we have to know what it looks like. So I'm going to go and plug it in my calculator and show you what we could do as one way to do this. So here's our calculator, TI-84. So we're going to graph that. And we had a -2x to the third. Now remember, go down, otherwise you'll write everything else up here again. And then we had plus 5x squared. And we're just switching x's for q's. Then minus 3x, and then plus 7. What about our window? Oh, yeah, that doesn't look good. How about maybe a -20 to a 20, maybe by factors of 5, and maybe another 20 and 20 and 5. And now let's see what it looks like. All right. So we have, it looks like it's going up, 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 and here it looks like it's going down, down, down. And so what we can say then is basically as x decreases without bound, the y is going to increase without bound. And here, as x increases without bound, then the y is going to decrease without bound. So let's write that down. So we had some kind of a, we'll just draw a kind of a shape like this, kind of like that. And so for A, we can say as x decreases without bound, as it decreases with bound, then the, I guess it really is not x this time, it's q. And that was t and stuff, but we know what we're talking about here. That's t, and that's m of t, but we switched it to f of x. That's okay. So as q decreases without bound, then c of q is going to increase without bound. So basically, it's going to keep going on up forever. And then corollary is as q increases without bound, the c of q is going to decrease without bound. Okay. Now, as a limit, well, we're going to say the limit, now we're going to write the right one this time, c of q as q approaches -infinity is going to go to, as it goes to -infinity, it's going to go to positive infinity. And then we can say the limit of C, well, of Q as Q goes to positive infinity is going to go to negative infinity. And are there any horizontal asymptotes? There does not appear to be any, so we can say none again. All right. So now we're supposed to numerically estimate the limits, show the numerical estimation table. So we have the limit of 3 minus 0.95 to the x. We want to start at 50, an increment of 100, and we're going to estimate to 1 decimal place. Okay. So I just made a table here. We'll hopefully get all those. It usually says to do 4, so I put 4. This one, we're going to have more because we're going by increments of 5,000. And so I decided if we're going to 3 decimal places and we have to have it the same 4 times, we're going to have probably a lot more than that. So let's go ahead and go to our calculator and start typing in these. So we'll have 50, 150, 250, and 350 in this equation. Okay, so let's go look at that. All right, so let's go over here. Now what we had was, we have 3, then minus, and we have 0.95 raised to the power, and our first one was 50. And so if we write that down, we get, and it's 2.92305, and I forget how many decimal places now, but that's okay. Now let's go back, and now we want to go to 150. And so we get 2.9995, and we had 1, 2, 3, 4, 5, 1, 2, 3, 4, and we'll put a 4 there. So we had that many. And let's go up here. Now we'll go up to 250. And so we get 2.99999. So that's 59. So that's as many decimal places as we had. We'll go one more, and we'll go to 350. And so now we have 2.99999, and it keeps going out further and further. And so we're pretty sure, looks like what happening here is we're going to go to 3, okay? So let's go back here, and let's write numbers down here that we had. So when we plugged in 50, we ended up with 2.92305. Here we had 2.999, well, okay, 99, and then we had 954, and then we had 2.99999 and 2.99999 as well. And it says to 1 decimal place. Okay, well, that one is going to be basically just 9. That's going to round that up, so it's going to be 3. That's going to be 3, and that's going to be 3. And so this is going to end up rounding to roughly 3.0. Now, is it ever going to reach there? No, but we're going to get a lot of 9s here the further out we get. Pretty soon we're going to hit a point on a calculator. It's going to give us an error because it's going to be too big of a number and we won't be able to do it, but it's going to get us pretty close to 3. All right, so the next one we want to estimate to 3 decimal places, so we'll want to make 4. So now if we remember to do that, we can do that. 4 decimal places. So let's go back to our calculator. Now let's clear this out. And so now we're taking, it was 6 times the ln of 10 plus, and now we had t, and we're starting with 500, and we're raising that to the -1, and so we could actually just do this. Let's take that back down, delete that. Well, no, go over here. Let's delete this. 500 to the -1. That's better. All right. So what do we get? So we get 13. Let's write this down. 13.8167. So we'll need to 4 decimal places. So that's to the 7. Now let's go ahead and do another one. This time it said add by 5,000. So this is going to give us actually, let's insert, make it 5,500. And here we get 13.8156. All right, so now let's go and do again. Now another 5,000. That's going to give us 1, and then we need a 0, and enter. So that gives us 13.8156 again. Except here you can see those are a little bit different, but to to 3 decimal places, you know, it's 6 and that's a 6. So let's keep going. And now we'll have up to 15,000. And so that's going to give us 13.8155. So now let's go again. And I think we had on our table 35,000. So we'll go all the way up to that. So now it's going to be 20,500. And so we get 13.8155 again. And so let's go back. We have a 5 here. So that's 13.8155. Now notice these now it's slowly getting to the 3 and a 3. So we're, you know, if we're going that far out, we could say we're getting pretty close to where we need to be. So now let's go to 30. And we still have that 3 there, so 13.8553. Okay. And now we do one last one because the table had it here. So that was a 5. And we get 13.85527. Okay. So now let's go back to our table and figure out what we think it's going to have for a limit. So here, again, to 3 decimal places, so that was 13.8167. That was 13.8156, 13.8156, 13.8155. And then we had 13.8155. And we had 13.8155. 13.8155, 13.8155, and you know we had 27. There was like a 3 something, 3 something, and so on. And so it looks like if we're rounding to 3 decimal places, this is going to go to approximately 13.816, because that would round to 6, 6, 6, 6, 6. That would round up to 6 also, as well as that one, and that would go up to a 7. So all the last ones of these would take it to the 6, okay? All right, so that's how we would do this one. Now let's go and see what we have next. Okay, so we're gonna take a break and then we'll come back with another set.